So yeah, thank you guys for being here. Appreciate it. Thank you guys for watching at home. If you're watching this after the fact. Kind of a surprise that I know we went remote today, but it's not really a surprise based on how things are going. So we're going to keep rolling along here. So you're definitely going to want to write some stuff down. And we'll get a chance to practice today. And you'll see some homework that I will send out today that you'll work on tomorrow. Okay, and that should kind of get us to Thanksgiving break. Okay. So first and foremost, though, make sure if you are here right now, open up the chat in that Google Meet and just type in your name so I can take attendance that way. Super easy for me to do it that way. So just drop your name in the chat right now, or say hi or say whatever. As long as you type something, it'll record that, and then I can go back in and take attendance. Cool. And then let's just get started. Take out something to write with, something to write on. Kind of continuing in chapter 2. 2.1 done, though. We did all of our vertex form stuff. Are there any questions about homework 2.1 that you're not sure about? I'm hoping that it was pretty easy. Considering we have this really nice setup with vertex form where we can just, pull out the important numbers and then look at A to tell if it's opening up and it's a minimum, or opening down and it's a maximum. So hopefully that A value made things really easy for you, and we can just kind of keep rolling. Okay. Again, this is, as much as it's like me talking into a camera in an empty room, I really want it to be as if you were sitting here. So when I ask questions today, and if you have an answer that you want to give, then unmute yourself and shout it out. It's a lot better for me and for you if we try to pretend like we're all in one big room. But let's roll through it. I know there's a little bit of glare up here. So I will do my best to exist below that. I tried to lift the camera up as high as I could. So 2.2 is where we're at. Hopefully that looks pretty good. We looked at vertex form of quadratics, which is really nice because we could see the vertex and we could figure out the orientation based on the sign of that leading coefficient. But we can't really tell much else from there. So what I wanted to do was give you a different way that these quadratics can look, and we can figure out some other stuff from there, plus a way to find the vertex as well. So that one's called vertex form. 2.2 looks at standard form. Okay, standard form. And the reason it's called standard form is because this is the way it's probably going to look most of the time when they give us a function to look at, right? The standard, right? The most common version of whatever. Okay. And it's just without parentheses, right? Vertex form had that inside part and the outside part. This one is just, everything's all multiplied out and it's just written in a nice order, okay? It's still quadratic, so the biggest power is still going to be 2, and it's definitely going to be there. And there could be powers less than that. There could be like a plus x or a plus of 2x or a minus of 4x, something like that. And there could be a number at the end too, some constant, plus 5 or minus 7 or whatever it is. But they're going to put it in that nice order. They're going to put the x squared one up front, then the x, and then the constant. Okay. So what I'm going to do over here is just kind of talk about stuff in general, with just letters. No numbers in there just yet. And then we'll play around with some ones that actually have some numbers and see what happens, see what we can figure out just by looking at the equation, and then how I'm going to give you a quick little shortcut on how to find the vertex when it's not written in vertex form. Okay, so here's standard form. Again, I could call it whatever I want: f of x, g of x, p of x, q of x. I'll call it f of x for now. Again, that's just y equals, right? We're just using function notation to tell them apart from one another. Leave a little space after this equal sign, because we'll put a letter up there in a second, but we'll have an x squared term, or we need that if it's going to be quadratic. But leave a little space, okay? Plus, leave a little space because we'll put a letter there as well. Plus an X term, maybe, could be there. So we'll leave a spot for that. And then plus, leave a little space, something at the end. Right? We'll have potentially a number at the end there. And maybe not, right? It could be plus 0, that's fine. But we've got that spot. Okay. And what I want to do is just give these some names, right? Kind of like we did with A, H, and K in vertex form, right? A was the one out front, and then HK was the vertex. I want to do the same thing here, right? Letters at the end of the alphabet are good for variables, but letters at the beginning of the alphabet are good for those numbers that we just don't know yet. But when I pick a function, I'm going to pick numbers for that, okay? The nice part about vertex form compared to standard form is that leading coefficient, whatever that number is right after the equal sign, we call them the same thing. They're both going to be A. And they really mean the same thing. A is still going to be whatever that was for vertex form, right? It's still going to be that vertical stretch or compression, right? I just wrote S/C, but that's what it means. And it's still going to tell us about that reflection. It's going to give us an idea if this thing opens up or if it opens down, right? If A is bigger than 0, if it's positive, then it's going to open up, right? If A is negative, if A is less than 0, it's still going to open down. That's still true, okay? And that's why we use the same letter. A for vertex form, A for standard form, it's the same number from one function in one form to the same function in another, right? So whatever that number is out there, definitely going to keep track of that to figure out, does it open up so it has a minimum, or does it open down so it has a maximum? Okay, but these two numbers are not H and K. Okay, they're not going to be the numbers for the vertex. They're going to do something else. So I don't want to call this one H and this one K because they're not necessarily going to be the spots for the vertex. And so I'm just going to pick a beginning of the alphabet. We have A. I'm just going to call this one B and this one C, right? A, B, and C for those three constants that, you know, once I look at an actual function, they're just going to be done. Okay. And I want to figure out what they do. I would like to be able to know, like, does this help me figure out something? So what I'm going to do for a second is I'm going to come over to my actual computer, present my screen, and I just want to graph a couple on Desmos and see if you can see anything. See if you can tell me anything just by looking. And this is the point where I'd love if you would like unmute yourself and tell me if you see something that you notice. Okay, so all right, y equals, let's say x squared plus 6x minus 2. And is there anything about, here, let's make that number a little smaller. Let's go like plus 3x, there we go. Is there anything that you notice about this function? Like about, well, we know what this number up in front did, right? That was a 1, it's a positive 1, so no surprise, this thing opens up. So there's my minimum right there, negative 1.5. negative 4. And really the important points are kind of marked off here, right? We've got a couple x-intercepts right there and right there at some weird numbers. There's our y-intercept and there's our vertex.
Did it change like where it was on the y-axis?
What do you mean?
Like it moved up and down, or in this case down.
Like where it's running into the y-axis, like right over here?
Well, instead of like the point being on the x-axis somewhere, like the low, like the minimum, it's like farther down.
Right, and like if I just did like plain old x squared, right, in blue right there, it's sitting there at 0, 0, right? But messing with these numbers for sure, and it's definitely going to kind of mess with where it is, like what location we've got for it. But what I want to try to figure out is like what part of this equation, like the A, the B, the C, what part can we be sure maybe without having to do any work at all. Like, tell me about one of the points that are on this. Let me do another one, like x squared plus x plus 1 or something like that. Or negative 2x squared minus 5x minus 4 or something like that. Like, is there something from the red one, the blue one, and the green one, just one of those numbers, either A, B, and C, A, B, or C, A, B, or C, that gives us guaranteed like one of those important points, an x-intercept, a y-intercept, something about the vertex?
Well, the last number, the minus 2, that's where like the y-intercept is.
Okay, so there's a minus 2. So this minus 2 right here, negative 2 is the y-intercept here. Is that true for the blue one as well? Is the plus 1, is that the location of the y-intercept here?
Yeah.
And the minus 4, is that the location of the vertex, the y-intercept right there?
Yeah.
Absolutely. Okay, we are guaranteed for sure. I'm gonna stop presenting because you got it. You nailed it. This number right here is always, always, always going to be the y-intercept. So that right there is my y-intercept. 0, comma, well, whatever c is. All right, from one function to the next, it's going to change. But that spot, that number at the end, will always be the y-intercept. Why? Well, y-intercept happens on the y-axis, right? So we haven't moved left or right from the origin. We're just going up or down to find where this thing runs into it. So x is still 0, right? We haven't changed this at all. We're just moving up or down. And so if x is 0, like this whole thing's gone, this whole thing's gone, whatever those were, the ax squared, the bx, those disappear. And so c for sure is going to be the y-intercept without having to do any work, which I really like. Kind of like in vertex form, there really wasn't any work to do to find the vertex. It was just there. Same thing for us in standard form. The y-intercept, boom, right there, nothing I have to do. Okay, so A's got a job. It tells us what we got in terms of orientation, right? Opens up or opens down, which helps us with mins and maxes. Okay, C for sure gives us the y-intercept. Okay, but what we would notice if we kept looking is that you can't really tell much else specifically about other important points along the way, x-intercepts or the vertex, okay? And obviously there's a lot of important points, but those are really the big ones, right? Where's the vertex, where's the y-intercept, and where are the x-intercepts if we have it, okay? And so the easiest one for us in 2.2, obviously, of course, is going to be the y-intercept. But the other easy one that just takes a little bit of work, and that's what I want to teach you today, is how to find the vertex, okay? Because that we know from vertex 1, of course, from the last one. What I want to be able to give you today is a really nice shortcut for how to find the vertex if it's written in standard form, not in vertex form, okay? And this one's going to take a little bit of work, okay? Not a ton of work, but it will take a little remembering of which number or which numbers, the A, the B, the C, or some combination, is going to help us find the vertex itself, okay? And so that's what I'm going to do. That's what I want to give you today. Now, there's definitely some stuff happening in the background that got us to this point that I'm about to give you a shortcut of. But if I explained right now where this shortcut comes from, I think it'll just confuse us because I'm kind of getting ahead of myself. The process to get to the shortcut, like how they figured it out in the first place, is from like section 2.5. So that's a couple weeks down the road that we're just not ready for. So I don't want to confuse you by giving you the reason why this works just yet. Okay, I'm going to give you the shortcut now. Then once we get to that point in 2.5, then I'll show it to you. Okay, so hopefully by now you just trust me. Trust me for now that it works, I promise, and you'll see we're going to do a bunch of them. They're all going to work. Here's the shortcut to find the vertex, some points where this graph turns. Okay, and I'm writing it pretty big because I have some stuff with A's and B's and stuff like all on the inside here because there's no numbers just yet. Okay, again, this is the shortcut part, and you can do it every time. Okay, it's really, really nice shortcut that just uses the numbers that are already there. We just have a little work to do to figure out what those numbers are. Okay, and I'm going to start with just the X part of the vertex. The Y part we'll figure out once we know X. Okay, here's the shortcut. The X part of the vertex, in vertex form, super easy. It's just whatever that H was, right? But in standard form, it doesn't look like that. So I have a little bit of work to do, okay? Here's what it looks like. The X part of the vertex is a fraction. We're going to have to do some dividing. And I will often try to pick really nice numbers so that when you do the division, they all go in nicely. So you don't actually end up with a fraction or a decimal. Sometimes it will, and I'll even show one for you today. You'll see one on the homework too. That makes it work. Okay, it's a fraction. Okay, on top of that fraction, okay, if the number in front of X is what we're calling B, the number on top of this fraction is negative B. And I really shouldn't say negative. It's just the opposite of B. So if like B was 5, this would be negative 5. Just the opposite sign. Keep the same number, but switch the sign. So if it starts positive, make it negative. But if it starts negative, so if this number in here was like a -4 to start already, then this up top here would be a +4. Just switch the sign. Okay, so the top of the fraction, I say negative B, I really just mean the opposite of B, okay? On the bottom, we're gonna take A and double it, okay? It's gonna be 2A. So whatever A is on the bottom, keep the sign the same, but just make it twice as big. That's the shortcut, okay? This comes from not super complicated math, but it's just a little bit more complicated than we're ready for at this point. I got to teach that process to you. So there you go. Okay, that's going to give you the X, and we have to start with that. Okay. So let's just try one. I'm gonna let's see if I can. I want to be able to kind of leave both in the view of all this to make it work. Okay. And we'll talk about the Y here in a second, but I wanted to just kind of get us to the point where we've got an X value. So I don't know, I'm just gonna make one up. So number 1, is that in the, yeah, it's in the glare. So I'm gonna come down to here, okay. F of X equals X squared plus 4X minus 1. Something like that, okay. F of X, X squared equal, F of X equals X squared plus 4X minus 1. And what I like to do, especially early on when I'm doing functions in standard form for the first time, I like to kind of come off on the side here and say, okay, A equals, B equals, and C equals. I kind of just like pull out the important numbers. I write them down so I know which ones I'm supposed to use for what. And you're going to see we're going to need this in 2.3 as well. Like A, B, and C are going to come back. We're going to look at standard form in 2.3 and then change it around. So just remember, A is just the number in front of X squared. Not the whole thing, but just the number. Okay, B is the number in front of X, and C is the number at the end. And so unmute yourself. I want this to be, a conversation that we have. If I don't write a number in front of X squared, it's there, but it's just invisible. What is that number if I don't write that
1.
Number? Good. A is 1. Good. And it's important to know that because I need A in the vertex, so I got to make sure I know which one I've got. B is the number in front of X. What do we got there?
4.
Good. And just the number 4. I'm not going to write 4X. It's just the B. It's just the number. And then what's C?
1.
Careful.
-1.
Good. The sign in front of the number we want to make sure we keep track of as well. Okay, cool. All right, first things first. What's the y-intercept? Shouldn't have to do any work. We just have to know which one to look at.
-1.
Good, nice. And you can write just -1, that's fine. Or you can write the point like 0, comma, -1, either one's fine. Okay, when you label it y-intercept, I know the x is 0, so you actually don't have to write that down. You could just say -1. Okay, cool. Now comes a little bit of the trickier part, is trying to figure out what the vertex is when it's written in standard form. And it's a point, but I have to figure out what that point is first, okay? And so I'm gonna leave this space blank for now. I'm just gonna come down here and do a little work to help me figure out what that is, okay? And what I know for sure, and again, I'll prove it to you in a couple of weeks, so just take my word for it right now. The x value of this vertex, I'm gonna write x equals, guaranteed to be -b over 2a. It's been proven, right? And I can prove it to you. It's just a little complicated, okay? -b over 2a, so I'm gonna write that down. And then all I'm gonna do is I'm gonna drop in b for b and a for a and see what I get. Okay, so if b from the function that was given to us is 4, I'm supposed to put the opposite of b on top. So I'll just put -4, right? Same number, switch a sign. On the bottom of this fraction is going to be 2 times whatever a is. A, since it wasn't there, it was just a 1. Good. Okay. I'm just going to kind of come over on this 4. Hopefully you can still see it. And then I'll work down from there. Cool. So that's -4 divided by 2 times 1, which is 2. What's -4 divided by 2?
-2.
Nice. A negative divided by a positive is negative. And because they go in evenly, the fraction can go away, and I just have that nice -2. There it is. There's the x value of my vertex, guaranteed for sure. Absolutely. Nothing I have to do to figure out what that x is. I just do -b over 2a. So that's the thing you got to start remembering. -b over 2a. That's the thing that's going to kind of get stuck in your brain here in the next couple of weeks. And then beyond. I mean, I use this in calculus. I really do. Stuff comes back for sure. Okay, cool. There's the x value. How are we going to use that to figure out the y value that goes with it if I know the function? What do you think we could do with this number, right? What can I do with this -b over 2a to figure out, okay, go to -2, where that point up and down is actually, where's the y value that goes? If this is all we've got, right? I don't have a graph to look at, let's say. I can't jump onto a graphing calculator, go to decimals.
I have no idea.
It's okay. We've got this function. I know what x is. It's -2.
Just plug in x.
Good. That's what the function's for. It's a function of x. And remember, f of x is really just y equals, right? We just call it f of x or g of x or h of x to tell them apart from each other. But remember, this is a relationship between an x and a y, that if I know x, all I have to do is plug it back into the function. I'm going to say f of whatever. I'm just going to plug in x. Okay? I've got the kind of relationship that exists between x and y, and if I know x, all I got to do is drop it in, and it should give me the y that goes with it. Okay? I'm just going to use good function notation to make sure I'm showing this off right. Okay? If you have f of x and you leave it with the x in there, that's why there's x's over here. Okay? But I don't want to leave x as x. I actually want to change x to -2. So when I come down to kind of like my next line of work under here, I don't want to say f of x equals. I want to change. So I'm going to take this. It's going to come down to here. I'm going to use it. I'm going to use the function. But I don't want to leave x as x. I want to drop in whatever number I just found to be the spot where this thing is going to take a turn. So I'm going to change this x on the inside to be -2, because that was the number that I found. And if I change this x on the left side of this function to be -2, that means every x that I've got in this function. Oh, I'm running out of space. Or parentheses, sorry, -1. Wherever there was an x in this function, I am now going to drop in -2 and see what I get. Okay, so don't say f of x equals -2 squared plus, no, f of -2 equals, right? Or hey, if x is 5, okay, f of 5 equals. Or x is 1/2, okay, f of 1/2. Whatever number you're gonna plug in, tell me that from the very beginning of whatever you're writing. Okay, f of x is just in general. That's the whole thing, right? That's the whole parabola gonna give me. I just want one spot where x is -2, and now I just let the math kind of take care of itself from here. I just have to do -2 squared, see what I get. Remember, we're just going to follow order of operations because we're not solving anything. We're just simplifying what's happening. So I'm just going to work my way down, right? Nothing inside the grouping symbols to do, nothing inside the parentheses that are just there. So I'm going to do exponents. What is -2 times itself?
4.
+4. Good. Now be really careful in the calculator. If you were to write, I got a lot going on over here. But if you were to write like -2 squared without the parentheses, the calculator reads a negative sign as -1 times. Like that right there is this right here. And then 2 squared next to it. It's going to do exponents first, like we should, and then give us -4, but we know better, right? A negative number times itself is positive. So be careful how you type that in. And that's why we like to use parentheses whenever we substitute. That's always good. Cool. So that was the only part of exponents to do. So I'm going to move down and look for any multiplication at the same time, and there it is. Sign in front matters. +4 times -2. When the signs are different, we get a negative. 4 times 2 is 8. Multiplication and division done. I'm just going to bring down this -1 so it's all in one spot. 4 minus 8. Start at 4, subtract 8, so I'm at -4, and then minus one more, -5. So f of -2 equals -5. And what that means, like there it is. There's the y value of the vertex. And what we should have, and I'm just going to share my screen again so you can see it, because the graph should prove it to us. It should work. That if I went in and I looked at x squared plus 4x minus 1, there's the vertex. There's the y-intercept, the two things that we are guaranteed for sure to be able to find from standard form. Easy. Y-intercept, just that last number, boom, done. The harder one, finding the vertex. Okay, -b/2a, see what you get. There's your x, plug it back in, there's your y. Cool? All good? Questions? All right, let's do another one. Let's do one where A is a little bit different. I'll keep this stuff up here for now, because I should have enough space. I'm just going to kind of visually separate it like that. I'll try to stay out of the glare. Let me know if you can't see anything. I should be able to kind of start right there. Number 2. We did f of x already, so let's pick a new one. Let's call it g of x. Let's go, I don't know, let's say like we'll stick with x squared. I like no, let's make it a value. How about 2x squared? Let's do that. 2x squared minus, I don't know. How about like 12x? and then plus 7, something like that. Okay, it's definitely quadratic because the biggest power is a 2. And it's in standard form because it goes x squared, then x, then the number. It's kind of written in that way on purpose so that we put the biggest power up front so we know what kind of function we're dealing with. Because if the biggest power was 3, it wouldn't be quadratic anymore. Or 4 or 5 or something like that wouldn't be quadratic. And this whole thing would fall apart. This works for quadratics, okay? And so what I like to do kind of early on while I'm doing this, whether I do it like just in my head or I actually write it down, that's kind of up to you, like A equals, B equals, and C equals, okay? Because showing that work, if I write down the correct numbers here, it's going to help me do this part, right? But even if I mess up and I write these numbers down wrong, but I use those incorrect numbers properly, I can get lots of partial credit for doing that. So if you make a small mistake here, and I know that you wrote it down wrong, but the rest of the work is right, you'll get a lot of points for that, which is good. Okay, so 2x squared minus 12x plus 7. All right, what's A? What's the number in front of x squared?
Two.
Sweet, thank you. What's B?
2.
What's our B?
Negative 12.
Good, sign in front, huge. Gotta keep track of that, good. And then C?
7.
Plenty.
7.
It's good. 7, perfect, thank you guys. Okay, cool. What I should be able to do right away without having to do much work, and this I'm gonna ask you to do this every time, what's the y-intercept?
7.
Guaranteed, and you can just write the number, that's cool, okay? If you wanna do it like I did the last one, you put like the 0.0 comma 7, that's good too. It might be even better, but this one's great. Well, I'm very happy with that right there. Okay, the next thing that I'm gonna ask is about the vertex. Okay, now that's a point, so I definitely have to write it as a point. It's a turning point, right? But I have to figure out where that is. And that's gonna take the work. And this is, I wanna see the work for sure, right? And I know that I have this really nice shortcut, okay? X is gonna, just the X part. So I like to say X equals so I know which part I'm solving for. And I also like to write down my shortcut without numbers in yet. I like to write down the negative B over 2A part. So I know what I'm doing, right? So I have some placeholders for me to drop in the correct numbers. And then I just, like a train of equality, just equals this, equals this, equals this, until I get myself to the best version of whatever that number is. And hopefully things divide nicely. And if they don't, fine. I'll just write the simplest version of what I got. So B is negative 12. And what I want on top of this fraction is negative B. The opposite of B. So if B is already negative 12, what number should I put on top?
12.
Positive 12.
Awesome. Okay, don't forget to just switch that sign. Okay. On the bottom goes 2 times whatever A is. A just also happens to be 2. Cool, no worries. So 12 on top, 2 times 2 on the bottom, so that's 4. And look, there we go. I pick nice numbers. I'm going to try to do as often as I can to pick really nice numbers so this works out well. 12 divided by 4 is just 3. And that's the X value of the vertex. Okay. And by showing me at least a couple of these steps, then I know you know what you're doing. And probably the most important one, honestly, though, is the first one, negative B over 2A. I want to make sure that you have that written down somewhere. Okay, now I want to figure out the y value that goes with it. So all I have to do is plug it back in, right? But my function is g. So what I want to say, like f of something, that was the other one. That was from number 1. I want to make sure that whatever the name of this function is the same name, quote unquote, that I use when I actually plug in the number. So I'm going to say g of whatever, right? Because the name of my function is this function g. But if I leave the x in here as x, that's telling whoever's reading this that I'm not actually plugging in a number yet. There's the whole function g of x, right? But I've got a specific number that I want to use. I know that I want to plug in 3. And I want my notation to indicate that super clearly. So I'm going to change this x on the inside here to a 3 so that whoever's reading this knows, okay, he's talking about function g, and he is stopping at x equals 3 and seeing the y value that goes with it. Okay, and that's what that notation clearly states, which is really nice. Cool. Now, by doing that, by changing x to 3, that's what I got to do. I have to change every single x in this problem, there's more than one, to a 3. Okay? But take a look at this first term, 2x squared. The only thing in this part right here that's being squared is just the x. Okay, this 2 out front is not being affected by that exponent. If it was, they would have had to put all of the 2x in a set of parentheses so that the 2 gets raised to that power as well. But because they did it, the only thing being raised to that second power is the x. So when I decide where to put parentheses with the 3 inside, I got to make sure I don't put the 2 in there with it. Right? The 2 stays on the outside. The 12 stays on the outside. And only the parentheses start for the substitution where the x is. Okay, but in there, I'm not going to leave it as x, right? The idea is to change that x to a 3 because that's what I said I was going to do with that whole g. Okay, now, this is Algebra 2. Okay, this is not 7th grade, where I need to see every single little step of arithmetic like we showed there. I just wanted to talk that through so I could mention a couple things with the substitution and the negative squared and all that. But realistically, I would love if we showed that step. I'm just going to share my screen, that's why I disappeared. I would love to just like see you write down that substitution just like that, and then jump into a calculator and let it do the rest of the work for you, okay? I don't need you to tell me how this all shakes out step by step, okay? Your 7th grade math teacher did all that work for you, okay, or whoever it was, right? I want you to just jump into a calculator and do that, right? Type it in correctly and see that it's -11. And then just like we did for the x, create a little train of equality that goes from left to right equals, what was it, -11. Done, okay? That's the y value that goes with it. Again, I know I'm sharing, I just wanted to show you the graph because the graph should back up whatever we thought was true. Okay, there's our function. Let's see, y-intercepts. Let's check for it. There it is, 0,7. Perfect. We were right there. Nice. And the vertex is just off screen a little bit, so I'm just going to click and drag. 3, -11. Perfect. Right? And there it is. Cool? Okay, questions? Sweet. Okay, what I want to do is give you just a couple to try. I'll give you like 5 minutes. I'll put up the answers, and then you guys are good to go. Okay. So I'm going to move myself to the board in the front because I already have them written down there because I liked these 3. Hopefully you can. I'm going to angle the camera up a little bit. How's that glare? Ugh, of course. Let me see. Hold on. If I can get a better angle so that the glare disappears. I don't have any books. My books, I'm using all my books to stack up there. Can you guys see that okay? Is that all right? Let me angle this up a little bit.
Yeah, looks good.
Okay, I'll read them out loud just to make sure. Okay, so the first one, so you got 3, 4, and 5. We did 1 and 2. All these just more practice. A of x equals x squared plus 6x minus 10. And again, if you want me to repeat anything, just let me know. Number 4, b of x equals 3x squared minus 12x plus 8. And then the last one, number 5, c of x equals negative 2x squared minus 10x plus 11. Okay, take a few minutes, find the y-intercept and the vertex. Okay, I'll give you a couple minutes to get out in front of me, and then I'll start putting up some solutions. But definitely want to have a calculator nearby to help you do all of that stuff. And just ask if you need clarification on what something says or how to do something. Happy to help. It's up in the glare. I guess it's okay. That's a little small. But there is kind of my setup for the beginning of that first one. I'll give you another minute and I'll put the answer down for that one. All right, answer coming for the first one. I like to write my y-intercept as a point, so you're going to see me write 0, comma, whatever it was. In this case, negative 10, because that was C. Vertex is going to take some work. So B was 6, so negative 6 over 2 times 1. So negative 6 divided by 2, so that's negative 3. And then let's plug it in. And because it was a of x, I'm going to say a of negative 3. Wherever there's an x, I'm going to put parentheses. In goes negative 3. I'll do the arithmetic just so you can see. Negative 3 squared is 9. 6 times negative 3, negative 18, minus 10. Negative 19. Okay, and you don't need to show those steps, but there they are in case you want to. That's cool. There you go. Here's the first one. Here's number 4. Just had a little more to do there just because we had that leading coefficient. And b was already negative, so just like number 2, I had to make the switch back to positive when I talk about negative b. Again, you don't have to show every single one of these steps, but if you like to, chance for some partial credit in case something goes wrong. But I really hope that you are just dropping this right in the calculator all at once, letting it do all the work for you. That's why we have them. They're so nice. Let's just use them. Okay. And then, so 5 will be a little bit trickier just because the numbers don't go in perfectly. You don't have a whole number for the vertex once you get there. I just want to show you that that's going to happen, and that's okay. You didn't do anything wrong if you get a number like that. Y-intercept, super nice, so easy. 0, comma, whatever that last number is, or just say the last number. You can just say 11. That's fine. Don't peek at this until you're ready if you haven't gotten there yet. Vertex will be something, so I'm going to give myself some space there. But I'm going to do the work. X equals negative 2a. It's already negative, so I got to make the positive. 2 times a is negative 2, so that's 10 divided by negative 4. And 4 doesn't go evenly into 10. So I know I'm not going to have a whole number answer here, and that's okay. The vertex is going to happen wherever it's going to happen. I just want to make sure that I write the best version of that, okay? And so a positive divided by a negative is negative, right? Opposite signs, when you're multiplying or dividing, you're going to get a negative. Same sign, and you get positive. And I could just simplify the fraction. I could call it, all right, divide both of them by 2. I could get 5 over 2. Or you drop it in the calculator and you get a decimal. And that decimal has an end to it. It's negative 2.5. And that works. That's a good one, right? Which means we can use it. Either one's fine. What you'll see is that sometimes fractions can be easier when you're dealing with squares and square roots and stuff. But those of us that do like decimals better, go for it. You've got a nice decimal, let's use it. If you can't, like if it's, 1.33333333 forever kind of thing, then you're stuck with the fraction. We'll just use that. But this one looks good, negative 2.5. And then I got to plug it in. C of negative 2.5. So we're, and I want to see this step. I want to see the step where you write C of negative 2.5. You show me you know what to do to find y, but then you could just plug it in all in one shot and let the calculator kind of do the rest of that work. Let me see if I can show you the steps that I would do, and then you guys are good. You guys are good to go if you got to go, but I'm just going to show you that last step. Negative 2, negative 2.5 squared minus 10 times negative 2.5. This is what I'd be typing in my calculator, plus 11. Cool, 23.5. I'll write that down over here, and then I'll copy it over here. 23.5. Cool, there you go. You guys are good. I will send out some homework. It's actually already on the announcement for today for cohort A, who saw this one yesterday. Okay, you guys are good. Thanks for being here. I really appreciate it. Just check Canvas over the next couple of days so you know what you need to do. But this should be our last mandatory Google Meet. Okay, we will meet back maybe Friday. We'll see. I'll see what's going on. But certainly next week, the week after Thanksgiving. All right. So have a great break if I don't see you, and thank you guys for being here. See ya.
See ya. Thank you.
You're welcome.